This lesson is going to be an introduction into graphing quadratic functions. So first of all, let's look what a quadratic function would look like. And before we've looked at linear functions, they were represented with y equals mx plus b, where m was the slope and b was the y-intercept. We always had two terms on the right side of the equation. In a quadratic function, we're going to have three terms on the right side. One of the terms is going to be x squared. This is what makes it quadratic. Then we'll have an x term and then a coefficient. This is going to be the y-intercept again, where it crosses the y-axis. Just for your information, this a right here is going to affect, the number in front of the x squared is going to affect how wide or narrow your parabola is. Now, what is a parabola? Quadratic functions always graph that looks like a U that could be upside down or upright like this, and the number in front of the x squared is going to indicate whether it's going to be a wider or a narrower. The C at the end, as we said, is always going to be the y-intercept where it crosses the y-axis, and the B term determines the horizontal shift. That's just a little information for you, but each of the numbers is significant. Let's look at some parabolas that we have and when we might use them. When you have a ball that is being hit or kicked, like passed, whatever, it's going to leave and go up into the air, and then it's going to come back down. If you were to graph this by time and distance, or the height, you could say, it would graph as a parabola, the shape of a parabola. Also, this shows again a baseball, and the relationship between time and height is going to be like a parabola. There's actually something from nature, the banana, that is shaped like a parabola. And there's some architecture that we use that is like a parabola, and that is like the Gateway Arch here in St. Louis. So let's just practice graphing a quadratic function. What we are going to do is we're going to make a little t-chart. So we are going to have the equation. We're going to put the equation right here. Now I said that there were going to be two terms, but in this one I said there were going to be three terms, but in this one you only see two terms on the right side. That means that the x term is going to be 0. So when one of the terms is 0, you will not see it. But you will know it's quadratic anytime that the first one is x squared. You know it's going to be quadratic. So what we're going to do is we're going to, we need some ordered pairs, and we're going to graph those ordered pairs. In order to have an ordered pair, you need an x and a y. So I'm going to give you the x value, and we're going to plug it into the equation, and that's going to give us the y value, and then we'll have the ordered pairs that we can graph. So we like to stay in the center of the graph, and since 0, 0 is in the center, we like 0 to be the middle number, and then we generally pick 2 on the left side of 0 and 2 on the right side. So generally we pick the numbers -2, -1, 0, 1, and 2. That keeps our parabola there on the graph that we can graph, kind of in the center. Now, what you need to know, when you plug in a number, it needs to go into parentheses. So here's our equation. If I plug in a -2 to x, I need to put it in parentheses. That changes the way it evaluates. So this would be -2 squared minus 2. According to order of operations, we always do exponents first. And -2 squared means -2 times -2, which is 4. So then you have 4 minus 2, and that equals 2. So our ordered pair would be -2 from the x, and then when we solved it, we got 2, so our ordered pair is -2, 2. So I graphed it there, -2, 2. If we plug in -1, we have -1 squared. That means -1 times -1, which is a positive 1. So we have a positive 1 minus 2, which is -1. So our ordered pair is -1, -1. I'll graph that for you. If you plug in 0, 0 squared is 0, minus 2 is a -2. So our ordered pair is 0, -2. There it is graphed. Now we plug in 1, 1 squared, or 1 times 1 is 1. 1 minus 2 is -1. So we have 1, -1. And when we plug in 2, 2 squared is 4. 4 minus 2 is 2, so we have 2, 2. Now what you'll notice here is that we have the shape of a parabola. Oh, let me back up. Let me draw it here for you. When you draw the parabola, it's going to look like this on one side. Then you have the mirror image on the other side. Now down here at the bottom, you don't want it to make it a V. It's kind of a gentle U shape like this. And then it's going to extend all the way off of the graph, getting a little wider as it goes on. So this is called a parabola. Now if you notice just the y values right here that we got, that right here in the center with the vertex, we saw that the y-intercept was -2, and this is where it crossed the y-axis. From there, notice we had -2, this one was -1, and this one was -1. This one was 2, and this one was 2. That's what creates the symmetry over here. You're always going to find that in a quadratic equation. Okay, so let's look at another example here. This time the equation is 2x² + 1. We know it's quadratic because we have an x squared. When we have x squared as our highest term, that is a quadratic function. Again, we only have two terms. The middle term is 0. It's not there. So we're going to plug in, and this is a little more involved. When we plug in the -2 to the x right here, we put it in parentheses, and we have to evaluate the parentheses or the exponent first right here. So you have to do the -2 squared. -2 times -2 is a +4. So then you have 4 times 2, which is 8. And 8 plus 1 is 9. So our order pair would be -2, 9. There it is on the graph. If we plug in a -1, we want to do this first. We have to do the -1 squared first. And -1 times -1 is a +1. And then we have 2 times 1, which is 2. And 2 plus 1 is 3. So our order pair is -1, 3. Graphing it here. If we plug in 0, 0 squared is 0, and 0 times 2 is 0. So this term goes away basically. And our order pair is 0, 1. If we plug in 1, we do 1 squared, which is 1, times 2, plus 1, and we get 3. We plug in 2, we have 2 squared first. 2 squared is 4. So we have 2 times 4 plus 1, which is 9. So our order pair is 2, 9. Notice again over here on the graph, it's a little narrower. The larger the number gets here in front of the x squared, actually the narrower that the parabola is going to be. So we're going to draw this up with a gentle curve there at the bottom, the best you can. Make it a little curvy. And there's our parabola. There's our quadratic function that we're graphing. Okay, so this one, if you're doing the assignment with me, is on punchline 14.1, if you have it in front of you. So here we have our equations. So we're going to plug in to x, and remember we're always going to do the exponent first. So if we plug in -2 to x, we have 3 times -2 squared. Do the exponent first. -2 times -2 is a +4. So we have 3 times 4, which is 12. So our order pair is -2, 12. If we plug in -1, -1 squared is 1. 1 times 3 is 3. So we have -1, 3. If we plug in 0, anything times 0 is 0. We'll graph 0, 0. If we plug in 1, we do the 1 squared first, which is 1. That gives us 1 times 3, which is 3. So our order pair is 1, 3. And if we plug in 2, do the exponent first. 2 squared is 4. So we have 3 times 4, which is 12. And that's 2, 12. Again, you will see here that from the 0 we went 3, 12, and 3, and 12. And here's our parabola. Oops, I need to do one more click so I have my last point up here. There it is. Notice that this one's even narrower than the last two. This number got larger. Last time it was a 2, and this time it's a 3. The larger that number gets, the narrower or skinnier that the parabola is going to be. So that is how we're going to do quadratic functions. Here's one. A soccer ball is kicked straight up into the air. The height of the ball, which is represented by h, so here's the height, after t seconds. So this time instead of x squared, we're using t, and t stands for time. Can be modeled by this equation, negative 16t squared plus 40t plus 2. What is the height of the ball after 2 seconds? So since we want 2 seconds, 2 is the time. So that's the number we want to plug in to find out what that is. Now, if we were to plug in 0 to this equation, we do the exponent first, which is 0. So this whole thing becomes 0. 40 times 0 is 0. So our ordered pair is simply 0, 2. If we plug in 1, 1 squared is 1. Negative 16 times 1 is negative 16. 40 times 1 is 40, plus 2. So our ordered pair would be 1 is 26. If we plug in 2, now remember the x is representative of the time. This is the time, so this is how many seconds. So after 1 second, and here's after 2 seconds, so 2 times 2 is 4. So we have negative 16 times 4 plus 80 plus 2. When we work that out, we see that it's 218. When we graph that, you will see, here is our graph. I'm trying to draw it. It's kind of tricky. Okay, so there it is. So the height of the ball after 2 seconds would be 18. That tells you right here at 2 seconds. See right here, here's 2 seconds. Notice that it crosses through the point right there at 18 feet. And you can see that the height of the ball at 1 second, here's 1 second, was 26 feet. So whatever you want for the number of seconds, you just plug that in for t, and whatever the y is, this is the y-axis, that will tell you the height. So you can figure out the height at any point during that kick. Okay, so this has been looking at quadratic functions. Basically, you're taking an equation, you're plugging in numbers to create ordered pairs, then you graph those ordered pairs, and it should create a parabola.